Yeah, recording has started now. Yes. So this is what you are seeing here. This is the engine. Okay. And what is our aim is to, first of all, understand the parts of the engine. If you look very carefully, those, I don't know, those who are in the campus, okay, even if as soon as the situation is a little bit good in the campus, I would say please inform to me and visit to the IC engine lab. Any one of you, okay? I just need a prior information that you are coming to the lab. And then there I can at least show you much better than the what I can do here. Okay, so just let us start from the top of the engine. If you just start from the top of the engine, here there is a kind of cover that it's a kind of the cover that is called head cover. You can, it is tightened by the bolt. You can remove the bolt and take it out the head cover. Once the head cover is come out, then what are the parts you can see that I will discuss it. Then if you look at very carefully, then what we are seeing here from this to here, see that is the up to here there is a sum. It is a not the from here to here it is a not an integral part. It is not a one part. If you look carefully, then you will find it out that this one is a separate part. And then from here to up to the this point, there is a one part, and then there is a last part that is attached with the main body. So what is the name of all these things? This part is called cylinder head. On the top of the cylinder head, there is a cover that is called head cover that can be also removed. Then it is coming, then what this part is called cylinder head. Cylinder head is bolted with this block, and this block is called cylinder block, engine block. Okay, this part is called engine block, and at the bottom of the engine block there is a space here, and you can say it is a lubricating oil storage or lube oil sump. So these are the three important parts: lubricating oil sump, engine block, cylinder head, and on the top of that there is a cylinder cover. When we are going to dismantle the each part, okay, how it looks like from the bottom side or from the top side, what are the parts are in-housed in the cylinder head or engine block. If I have to see the liner and the piston, okay, where I can go and check it out. If I have to find out the cylinder intake valves or exhaust valves, where I can get it. So these are the things we are going to learn about it. Then, okay. Okay, so this is the not very good quality of the engine cut section, but yes, we can at least get some of the information. Can you tell me what is the name of this part that you are looking at the bottom? What is this part?
Shaft.
What? Which shaft?
Crankshaft.
That is the crankshaft. Okay. And then cranks, this part, what is the name of this part or this part that is connected to the crankshaft? One end is connected to the crankshaft, other is connected to the something else. What is the name of that part?
Connecting rod.
Connecting rod. Very good. And then this one?
Piston.
Piston. And then this cut section, cylindrical surface, whatever you can see here. This one or this one?
Combustion chamber.
Combustion chamber, or it's better you can say line. Okay, that's really very good. What about these two things? This part and this part, or this part?
Inlet and outlet.
Inlet and an outlet. In other words, we can say it is intake valve or exhaust valve. Okay, that's really very good. How many cylinders are here?
4.
4 cylinder. Okay, each cylinder. So it is a 4-cylinder engine. Right now, which only we can say it is a 4-cylinder engine, and each cylinder has 2 valves. One for the intake, other for the exhaust. Okay, that's really very good. Now, as I told you that cylinder head, as soon as you remove the cylinder head cover, you will see such kind of the things inside the cylinder head, and this is the bottom surface of the cylinder head, and that is the engine block. If I'm and this surface of the cylinder head and this surface of the cylinder block are matching with each other. Let us discuss first of all the cylinder head. This surface, how we can see, we can look it from the combustion chamber sides. Can you tell me what are these things I'm looking in the cylinder head? What are all these things?
Wall. Uh, Inlet.
Intake and exhaust valve.
Very good. Intake and exhaust valves. Okay. And the cylinder head belongs to the which kind of the engine? How many cylinders it was?
4.
4 cylinder.
4. Because you are saying that there are 4 pair of the intake and exhaust valves. So you are saying it's a 4-cylinder engine. What else you can observe it here about? Just look it very carefully. I don't know whether is enough resolution. Let me improve little bit, increase the size. Yeah, it is fine. If you look carefully, either this one or this one, can you tell me something difference that you can observe here?
The size of intake and exhaust valve are different.
Very good observation. Very good. So it is very clear, at least from this figure, that size of the valves are different. One valve has a smaller size compared to the others. That is true for all cylinders. Now, which one is now with this differentiation? Can we judge or can we say something? Which one is the intake valve and which one is the exhaust valve? And why? Or it is not possible to judge it based on this observation. There are 2 valves and the size of the one of the valve is smaller compared to the others. With this observation, is it possible to find it out which valve is intake valve and which one is the exhaust valve?
Sir, I think the intake valve would be smaller.
Intake valve would be the smaller one. Okay. Anyone else Do you?
I think the intake wall will be bigger.
Intake valve is the bigger. That's really very good. We need at least 2, 3 different kind of the view. Then we can discuss. That's right. Very good. So yeah, so that is the probability that we have. Either this one, a smaller one is the intake valve or the exhaust valve. So one of you has told that the bigger one is the intake valve. What is the logic behind that? Do you have any things, or it is just a guess? Even if it is a guess, it is really very good. But if you have something logic behind that, please explain yourself.
Sir, I think that more space for the air will be there to enter the combustion chamber if intake wall will be bigger.
Okay, that's really very good logic. And
Sir,
what
very high
about
pressure for exit wall
very high pressure for?
for the gases to be removed from the chamber.
Yeah, okay. Therefore,
So small exit valve can work.
okay, that's really very good. Yeah, yeah, that's really very good. It's perfectly fine. So I can't see the name of your friends, but whoever explained these things, it's really very good. That in general, in all the engine, the intake valve size of the intake valve is slightly bigger than the exhaust size of the exhaust valve. Intake valve has a slightly bigger in size than the exhaust valve. As your friend has explained the reason behind that, see the things is when you are designing the engine, okay, or when you are manufacturing the engine, there are so many criteria. Based on that, you have to decide the so many parameters. And one of the important or one of the very important kind of the parameter is to how to maximize the power output of the engine. Okay, there are so many parameters that you can tune in order to get the maximum power output at any operating condition of the engine. One of them, but one main thing is that unless we don't have enough energy inside the combustion chamber, how we can get the maximum output? So how we can maximize the energy content of the mixture inside the combustion chamber, so that when the combustion takes place, it can produce more energy and then we can get more power. So, but the other thing is that we cannot put as much as fuel as we want so that the energy content or amount of the energy can be maximized. There is a proportionality between the fuel and air. Later we will study about that what is the air fuel ratio or equivalence ratio or relative air fuel ratio. There we will discuss a little bit more about that. What is the, I'm saying the relative proportion. We can inject the amount of the fuel proportional to the amount of the air that is coming inside the combustion chamber. So in order to give more amount of the fuel, first of all, we need to maximize the amount of the air that is coming through during the intake stroke or through the intake valves. Some of the terminology I'm using it even though I have not explained or not um, explained in the class. This is the second class, like intake stroke I'm saying or something kind of things. Bear with me right now, because I need to use such kind of the terminology to explain some of the things. And when I will explain more about the intake stroker and all these things, I will try to correlate once again. I hope some of you may be understandings, but maybe some of you have some problem. So if you are not able to understand, please stop me and ask the question. I will try to explain even at this point in a very simple version. So what I was saying that we need to maximize the amount of the air so that we can inject more amount of the proportionate amount of the fuel, and then we can get more power output. Now you know that intake in the engine, in general, in all the engine, in general, I am saying there are different kind of the engine based on the how the air is coming inside the combustion chamber. One is called natural aspirated engine. Natural aspirated engine, where the air comes into the combustion chamber from the atmosphere at the normal pressure. Or we can say there is a air comes inside the combustion chamber only by the action of the piston, only by the action of the piston. Or that the piston creates the suction pressure, and then because of the temperature difference between the intake manifold and the combustion chamber, the air flows from the atmosphere to the combustion chamber. So there was no any kind of the external force or external pressure. Such kind of the engine is called natural aspirated engine. And there's another kind of the engine that is called turbocharged engine, where the air is forced to go into the combustion chamber. So the pressure in the intake manifold is higher than the atmospheric pressure. That kind of the engine is called turbocharged engine. Details I will discuss later on. So in the natural aspirated engine, the pressure, maximum pressure that is coming inside the combustion in the manifold is going to be 1 bar. So our aim is to make it a little bit larger areas so that more amount of the air can come into the combustion chamber. But some of you may argue that after the combustion, we need to flash out the combustion product so that in the next cycle, the fresh air again come inside the combustion chamber. So as your friend has explained it, that during the exhaust stroke, when the exhaust valve opens, at that time, the pressure inside the combustion chamber is above than the atmospheric pressure, slightly above than the atmospheric pressure. It depends upon the other parameters also, but yes, it is above than the atmospheric pressure. So because of this temperature difference between the combustion chamber and the exhaust manifold, some of the exhaust product goes out to the from the combustion chamber. So even if this part is or size is smaller, since the combustion product pressure was itself is the higher than the atmospheric pressure, for as soon as it opens, it is possible to flash out all the combustion products of the combustion from the smaller, even a smaller size of the exhaust valve. And therefore there is a slightly difference between the size of the intake and the exhaust valve. And that is true, almost true. So whenever a cylinder head is kept in front of you, okay, look it very carefully and find it out which one has a smaller or bigger size, and accordingly you will be in the position to find it out which one is the intake valve and which one is the exhaust valve. So that is one of the very important observation, and that way you can find it out the intake and the exhaust valve.
Sir, so
And
if we increase the size of exhaust valve to the size of intake valve, will there be a problem or not?
yes, there's another thing is that one thing is called a space problem. You have very small space. It is such a smaller space, okay, that how we can accommodate so many things here. So we don't have unlimited space here. In that way that we can increase the size of the exhaust valve also to make it both equals. And if we have a space, okay, suppose even if we have some flexibility that we can increase the size of any of the valves, so it's better to always technically good to increase the size of the intake valve so that you can maximize the amount of the air. Because why unnecessary I would increase the size of the exhaust valve? So we don't need to. If in the engine, it is not based on the wish, okay, that okay, my wish is to increase this one or that one. We need to increase or decrease or change any parameters in order to optimize the certain parameter of output parameters. So depending upon how we can maximize our targeted output, we have to play with that. So if the space is available to you, okay, it's better to increase the size of the intake valve so that you can increase the air content inside the combustion chamber. Exhaust product is anyways going to be out because the pressure at the time of the exhaust valve opens is anyways higher than the atmospheric pressure. And then what I can tell you, what you are seeing here, there are two valves per cylinder. Nowadays, at least those who have a car at your home, I suppose even it is a 4 or 5 years old or something like that. You will find it out your engine has a 4 valves per cylinder. 4 valves. So now again we are even in this smaller space, we are trying to increase the number of valves so that more amount of somehow it comes inside the combustion chamber, and obviously it has to go out also. So that's the things.
Sir, do these valves stay open for the entire stroke, or like they open and close somehow?
Yes, that's a really very good question. At this stage, these questions is expected, and that's I'm very happy that you are asking this question. No, it's not like that. At this stage, I can say it's not like that. The intake and exhaust valve opens only for the certain duration in a one cycle. And then it is going to be closed. If it is going to be remain open, then you cannot create the pressure inside the combustion chamber. And if you cannot create the pressure, then you cannot get the work output. So at this point of time, let me tell you that it is going to be open only one valve is opens. Okay, in another way, let me explain, even though uh, I'm rich at that point. Right now, let me explain in a very, I don't know. Okay, let me explain even. There are 4 strokes. During the intake strokes, the intake valve opens, okay, and piston goes down from the top to the bottom, and it creates the suction. It creates the vacuum. Once it creates the vacuum, the pressure inside the combustion chamber is lower than the atmospheric pressure, and the pressure inside the intake manifold is, let us say, atmospheric pressure. So the air will flow from the atmosphere to the combustion chamber. And in that way, that is called intake stroke, in which the intake valve opens and the air comes inside the combustion chamber. After when piston reaches at the bottom, okay, and after even some times, intake valve is going to be closed, exhaust valve will be also closed. So the combustion chamber is completely sealed from the atmosphere. There is no interaction between the combustion chamber and the atmosphere. And then piston comes up. During its coming, it is going to compress the air and fuel, you can say also. And then when piston is about to reach at the top of the combustion chamber, the combustion is going to be takes place. The pressure and temperature of the inside the combustion chamber is going to be rise, and then that pressure is going to push the piston downwards. So the piston is again going down, and that is our power stroke. And then piston again goes down at the bottom, and then we get the power output. And then when the piston is coming up again, then the exhaust valve is going to be open, and then all the combustion product is going to be flash out from the combustion chamber to the atmosphere. So that is called one cycle. In one cycle, during the intake stroke, your intake valve is opens. During the compression and the combustion, both valves are in closed position. And during the exhaust stroke, it is the one in exhaust valve is going to be open. How these valves open and close, that is called valve timing diagram. And that we are going to discuss after 3-4 classes. How it opens, what are the mechanism through which the valves opens, we are also going to learn after 1 or 2 classes. So is it clear?
Yes, sir.
Yeah. Okay, so I was explaining about this size and why we have kept a different size. Now I can also explain you that now modern engine has a 4 valves per cylinder, 2 for the intake, 2 for the exhaust valves. Okay, so yeah, so that's we can discuss this part. Any questions apart from that? Any sort of the questions, whatever it is coming in your mind, please come up. We will discuss.
Sir, here also the outer diameter of those walls is different. Why is that?
Are you saying that the diameter of these two valves are different? Is it you are saying? It is what you are saying?
Not the holes, but the sir, the
Yeah,
outer diameter. Yeah.
outer diameter, which you are saying this one?
Yes, sir.
Okay, that's fine. Okay, that's really very good observation. So see the things, this valve, okay, is a not the integral part of the cylinder head. You can take it out, this valve. Okay, there is a provision, you can take it out. And whatever you see here, okay, it is a slightly bigger than that. And if you look very carefully, the shape at this in the cylinder head, it is a kind of slightly conical shape. Your valve, surface of the valve and surface of the cylinder head is not in one plane. The surface of the cylinder block and the surface of the valve is not in one plane. It has this one is slightly inside. It is slightly inside it. So, and it has a conical shape. So in just slightly inside, it is going to be completely fixed. It is fixed in such a way that is completely going to be leak proof. If there's even slight leak, you are going to lose the power output, because you know that in the first class we have already discussed the pressure is inside the combustion chamber is very high. And mechanically, you can assume that how good this kind of the design that mechanically we are sealing this combustion chamber where the pressure is around 50 bar, or it's going to vary from 20 bar to 80-90 bar depending upon the kind of the engine and depending upon the operating range of the engine. Mechanically, believe me, 2 bar or 5 bar even, wherever you make any sort of that device, and if the objective is to make it leak proof, and it's mechanically leak proof, is one of the toughest part and one of the toughest things, that how you can do the mechanically leak proof. So therefore, it is a kind of the conical shapes, and the back side of this valve is also has a conical shape. I will show you later on in the shape how these things is like that, and it is going to be completely sealed. That is called valve seat. That is called valve seat, on which it goes and completely sits on the cylinder head. Yes, it is slightly, and this is a slightly bigger than that, but inside it, it is going to be conical, that is going to be completely fit as per the diameter of the valves. Have I, am I explained to you correctly or clear it is?
Yes, sir.
Yeah. Something else?
Sir, also, can you explain once what is which surface is the top surface and how these parts are attached?
Yeah, that's really very good. Okay. As I told you, this is the cylinder head. Okay. So what we are seeing right now at this surface, when I can remove the cylinder head, and if I will look at this surface, at this plate, that is what we can look at here, this part. So this, it means this surface we can see from the combustion chamber. If we sit here, look at upward, then we will see that part. This part and the back side of the cylinder head, it is showing here. So this surface of the cylinder head and this surface of the cylinder block is going to match with each other. And this figure is showing the back side of the cylinder head. Is it clear? Is it, visualization is clear?
Sir, but in the cylinder block, we only have 4 openings. But in the head, we have 8 valves.
Yeah, that's what I'm saying. Each, this is called cylinder liner. Okay. This is called cylinder. It is a 4-cylinder liner, 4-cylinder engine. Each block or each cylinder liner will contain 2 valves, because in each block, in each cylinder, it requires air to come in and it requires exhaust product to go out. So that one is called intake valve, through which the fresh air comes into the combustion chamber, and other block, it is other part, this part is called exhaust valve, through which the exhaust product goes out from the combustion chamber. So here is the 4, here is the 8. It is because each cylinder contains 2 valves. So therefore here it is, there are 8 valves. It's okay, clear? Each cylinder should contains at least 2 valves, through which the air comes in and the exhaust product goes out. So if it is a 2-cylinder engine, then in the cylinder head you can see 4 valves. If it is a 2 valves per cylinder, as I am explaining you, in the modern engine we have 4 valves per cylinder. So if you open the cylinder block nowadays, okay, and if it is a 4-cylinder engine, you will find it out here 16 valves. Okay. Is there any else question?
Why are there holes in the middle?
Yes, that's really very good. What are these? All these are kind of the holes. And also you can see the holes on the cylinder block also, because these two surfaces are the matching surface. What are these block holes here? Anybody can explain to me?
These can be keyholes to hold cylinder. hold
There are
parallel to
so
each other.
many. There are so many. You can see
That
here. There are so many. We don't need so
to
many holes to
dissipate,
tighten it to the cylinder block.
to dissipate the heat.
Do you think it is going to open to the atmosphere? To
Mm,
dissipate the heat is very fine. Okay, but how?
To decrease the weight of engine.
To decrease the weight of wind. Okay, that's it. Okay, if you have pointed out these things, that's really very good. The cylinder head. The cylinder head is not a solid surface, a solid block. Inside it is a very integrated kind of the shape, and it is a hollow. You can see here. Even inside it, it is a it is a very integrated shape. Okay, and that's fine. It is the reason what your friend is saying, so that it is we don't make it a solid in order to get it a lighter weight and save the materials. But still, it is not solved that what is this holes.
so for cooling liquid to go through.
Very good. That's really very good. These are the some of the holes are used for the cooling purpose. How it is, I'm explaining. And some of the holes, that is through hole, okay, through hole in the block cylinder head. These are the used for to tighten the head to the block. And some of the blind holes, these are the holes used for the cooling purpose. You know that we will study later on. There are two kind of the coolings used in the engine. Either air cooled engine or it is a water cooled engine or liquid cooled, whatever. Coolant can be anything. So air cooled and water cooled engine. Can you anyone give me the example of air cooled engine that is normally used?
So
Air cooled.
two-wheeler engine. Two-wheeler engine.
Yeah, two-wheeler engine. And how you are sure that it is a air cooled engine?
Sir, fins present on the engine.
Very good. That's really very good. Yeah. At least from the outside, we can say that is the fins. Then the fins is used to dissipate the heat. Okay. To at least in India, whatever we see general kind of the two-wheelers. Okay. I'm not saying some of the very advanced two-wheeler. Okay. There are water-cooled two-wheeler engine also in the market, but it's very costly. But in general, whatever you see, it is an air-cooled engine. So what air-cooled engine? In water-cooled engine, okay, the coolant flows through the cylinder head and then it goes to the block and then it circulates around the cylinder liner and then it goes out. Okay, so these holes, if you tighten it, these holes and holes in the cylinder head and the holes in the cylinder block are going to match completely. So in that way, the coolant that is first of all flow into the cylinder head. It will go to the cylinder block, it will circulate and it cool down the relevant parts and then it goes out. So these holes are used for the coolant flowing from the cylinder head to the cylinder block. Okay. Anything else? That's really very good. I think we have almost covered, but if there's anything else, any observation or any question?
Sir, you said that the walls are like frustum of holes, like tapering, right?
Yeah.
They are.
Hmm.
Sir, so why is the diameter bigger? Like, shouldn't it be smaller because the pressure on the other side is larger? So, like, we would be choosing a ship.
Which one is this one you were saying why it is larger?
Yes, sir. Shouldn't it be actually smaller? Because like
It is it it is if I can say that the surface of cylinder cylinder head and surface of the valve is not lying on the one plane. Okay, so the what is the gap between these two planes? It is hardly it is going to be 1 or 2 mm, 1 or 2 mm. In the picture it may show you the very large. It's very small and it is a kind of the frustum or conical shapes, and it is going to be sit inside it that. It is slightly frustum in that in such a way that it, and also the shape and of the cylinder head, of the valve is also slightly cylindrical shapes, is to make in such a way that it completely seal with each other. If you it is going to be very straight way here and the straight way also the cylinder walls also, it might be that there is no perfect sealing is going to be there. Okay, so it makes slightly frustum kind of the things so that it can seal completely, and
sir,
it
but
makes
like the face that we are seeing, it
yeah.
should be smaller. Like the area of the valve, shouldn't it be smaller than the face on the other side?
Oh, you are saying that let us make it, this one is bigger than the this size and let it be extruded little bit. That is what you want to say?
No, sir. Like I'm saying that this valve, like if it's a frustum, like the pressure on the other side, like this is the face that we are seeing. On the
Yeah.
other side, the pressure would be larger, right?
No, here you are saying in the back side of this part,
Yes, sir.
the pressure is the atmospheric pressure, maximum. Here in the inside, if you are saying the back side of this surface, okay, through it is open to the atmosphere. This is either it is with intake manifold or it is exhaust manifold. That is the atmosphere. That is the maximum pressure. If it is natural aspirated engine, it is the atmospheric pressure. The pressure will be higher at this surface, not on the back side of this surface.
Okay, sir.
Okay. Okay. Let me go to the another. This is not the showing the complete design of the engine. So that's a bad. There's a little bit confusion. This part, okay. This is the part of the intake manifold and the intake manifold, and this is exhaust manifold. Manifold is open to the atmosphere. So the back side of this, the back side of the valves is the maximum, it is the in atmospheric pressure. The combustion is going to be takes place at this surface or here, where the pressure will be very high. So the pressure is going to be applied in what way? It is going to apply on in the direction of the going inside this our screen.
Yeah, sir. That was the confusion I was having. I thought it was the other way.
Okay, that's fine. Should I move to the next slides, or if have any questions, anyone? That's really very good. Don't let me go. Ask as much as question. That's really very important. Okay. Now the next part of the engine. I hope we have a time. Oh, we are almost okay. That's fine. We still have a 2-3 minute time. The next thing is that we have a piston and connecting rod assembly. So this part is our piston. This is our connecting rod. Connecting rod has two ends. One end is connected to the piston, that is called a smaller end. And the another end of the connecting rod, that is called big end, it is connected to which part of the engine? The big end of the connecting rod is connected to which part of the engine?
Crankshaft.
Crankshaft.
Crankshaft. Very good. So this one is connected to the big end is connected to the crankshaft. Smaller end of the connecting rod is connected to the piston. So we have a piston and connecting rod assembly, and that's really very important to understand the geometry of the piston. The geometry of the piston itself is another domain of the research in the IC engine area. What should be the shape of the piston? Okay. How many rings are going to be there? If you remember in the last class, we discussed that pressure is very high inside the combustion chamber and how we are going to seal it. Okay, from the cylinder head, as we can see, there are valves and valves is going to be sealed. But in the other end of the combustion chamber, how it is going to be sealed? That is, we are going to learn about the piston rings. How many piston rings should be there? What should be the shape of the top part of the piston? These are the really very important in the IC engine area, and particularly this is going to be even more important if you are going to deal with the diesel engine. There is a difference in the shape of the piston between the petrol engine and the diesel engine. This is, I mean, it's a kind of that you can, if you see the way you can see the cylinder block, and then you can find it out which one is the intake valve and the exhaust valve. The similar way, there is a possibility that if you can see the piston, and then you can say that this piston belongs to the diesel engine or it belongs to the gasoline engine. In general, I'm always sometimes using in general, I'm not saying it is always, because as we go at the progress in the course, we'll find it out. Some of the statement what I'm making here, it is going, I will change it later on. So therefore, I'm using in general. In general, there is you can differentiate between the diesel and the gasoline engine pistons, just to see the pistons, and you can say it is diesel engine piston or it is a gasoline engine piston, because the shape of the piston is different. Connecting rod is used in order to transfer the power from the combustion chamber to the crankshaft, through which we use the useful power. So details about the pistons and later on we'll study it in the next class. That's really very good discussions we have this time. That's really very good. I'm very happy the way you are asking the questions. Please continue that kind of the two-way communications. We should have a two-way kind of the communication. It should never be one-way communication. One-way communication is always going to be boring. So that's really very good. Thank you very much. You may have a course classes now. So we will stop here.